talking about office ergonomics deficiencies in computer workstation design. The objective is to study and identify ergonomics deficiencies in computer workstation design in typical office. Physical measurements and questionnaire were used to study 40 workstations. 40 workstations. Major ergonomics deficiencies were found in physical design and layout of the workstations, employees' postures, work practice, and training. The consequences in terms of user health and auto problems were significant. 45% of the employers used non-adjustable chairs. 48% of computer faced windows. 90% of the employees use computers more than 4 hours a day. 45% of the employees adopt bent and support back posture. And 20% use office tables for computer. Major problems reported were eye strain, about 85%, shoulder pains, 45%, back pain, 43%, arm pain, 35%, wrist pain, 30%, and neck pain, 30%. These results indicated serious ergonomics deficiencies in office computers workstation design, layout, and usage. Strategies to reduce and eliminate ergonomic deficiencies in computer workstation design were suggested. So nowadays, it is practically impossible to find an office or a shop floor without a computer workstation. It needs to use computers increase as computer technology advances and software and computer package are being developed. As a result, occupational health and safety problems are continuously increasing. This obviously can lead to reduced performance and dissatisfactory. Ergonomics. Ergonomics. Ergonomics is the science and technology of fitting the activities and environment to the abilities, dimensions, and needs for people to improve performance while enhancing comfort and health and safety. The efficiencies of human-computer interaction, comfort, health, and user safety can be improved by applying ergonomics principles. Essence developed a classical ergonomics framework and identified factors that affect human performance. These factors include task characteristics, user issues, environment factors, and human-computer interaction. The element of a work system, such as worker, equipment, environment, tasks, and organization's interaction when work is performed. A research model that incorporates these variables was developed. The study found that screen glares, yes, found that the screen glare, fatigue, and awkward postures were the most important factors contributing to ocular general musculoskeletal musculoskeletal upper body and physical symptoms. Workstation designs significantly affect working posture, which in turn contribute contribute to physical symptoms. Another model of a work system with components, technology, organization, person, task, and an environment shows that the objective of work system design is to optimize the whole system rather than maximize just one component. People should be central focus, and the other factors should be designed to help the person work effectively and comfortably. Research studies showed that many cases of shoulder and neck pain were caused by improper design or use of furniture. Users should position their head so that minimum stress is put on the neck muscles. The recommended wheeling angle is about 15% 15 angle to 30 angle. The position of video display terminal VDT relative to eye can influence visual strain. The two main parameters of VDT positions are the viewing distance from the eye to the screen and the height of the visual target related to the eye. Lighting is an important visual environmental factor for a computer workstation. So Wendy, researcher, described various types of gray and recommended methods for reducing gray for reflected and direct gray by proper positioning of the screen. Using a light focusing diffuser, adding an anti-glare filter, controlling the light source, and a proper adjustment of the screen. Noise can disrupt the quality, can disrupt the ability to concentrate and may reduce stress. The researcher provided solutions to handle noise problems in computer workstations. Keyboard and mouse are the common interface used these days. The optimal posture of the wrist is to keep the wrist stretched and free from extensions or frictions and ulnar. Yes, free from extension or friction and ulnar deviations so as to minimize stress. So when the researcher made recommendations for an ergonomics and comfortable use of keyboard and mouse. They include stability, slope, force, wrist pad, surface, and space for environment. Different layout of VDT workstations were studied. Researcher named Sotoyama and the team recommended desk height to be adjustable, so the user height and the monitor to be set closer to the keyboard to provide a small ocular surface area. Yes, a smaller ocular surface area. The amount of phobia. The amount of phobia is smaller in downward than in upper gaze. Yes, in upper gaze, from a psychological standpoint, dark merchants chip dark merchant chef nearer include during downward gaze. This indicated that VDT worker required less visual effort and gain more visual effort with glazing downward. So Wendy made several recommendations to improve computer workstation design with regard to work surface and chair. Work practice is an important issue for computer workstation users, regardless of how well a workstation is designed. If users have to work in a static posture for a long period, the workstation can contribute to performance, comfort, and health problems. So Wendy recommended computer users to take a minimum 15-minute break from working after 2 hours of continuous computer work. Researchers found that at least some improvement in body part discomfort level could be attributed to mandatory rest break. Yes, attribute to mandatory rest break. Occupational illnesses such as back, neck, shoulder, arm, and hand and wrist pain were related to intensive keyboard work. Poor psychological work environment being female. Yes, the pain were related to intensive keyboard work, chair, and workstation characteristics, increased job demand, poor psychological work environment, and being female. Researchers reported that cumulative trauma disorder. Yes, reported the cumulative trauma disorder of hand and wrist was the most common disabling injury experienced by VDT operators. Ergonomics trainings programs have shown positive effects in reducing computer workstation symptoms. Yes, workstations symptoms. VDT operators need proper training on how to maintain a correct posture and adjust their workstations. Ergonomic provide some ground rules in the design of an education and training program for computer workstation. The training program were effective in producing positive changes in workstation configuration and postures and reducing the severities of symptoms. There was also an important improvement in productivity. A series of multinational ergonomics intervention studies were conducted to investigate the effect of VDT work on musculoskeletal, musculoskeletal visual ergonomics and physical psychosocial factor. These studies laid out a basic methodological structure for various ergonomics interventions. The interventions included ergonomic information and training, workstation redesign, and providing new facilities and improved working conditions. A significant reduction in health symptoms such as neck and shoulder pain, eye problems, and other ergonomics problem was observed in various groups after the interventions. Although a lot of research have been conducted in this area, it is believed implementations of ergonomics in the office environment is somewhat limited, especially in developing nations. And the ergonomic studies of a computer workstation is an office environment in the oil industry was the interest. The objective of this research was to study and identify ergonomics deficiencies in computer workstations in typical office in an oil company and suggest strategies to reduce or eliminate these deficiencies to improve occupational health and safety and employee performance and certifications. The method the method the methodology pursues in identifying, yes, they pursued in identifying ergonomics deficiencies in computer workstations involved a physical measurement of the relevant dimensions of workstation, administering administering administering
Administering.
administering a checklist to collect employee information and a questionnaire on employee perception on various work attributes. The checklist and the questionnaire were constructed by the authors on the basis of the relevant information on computer workstation design in the literature. A list of the required major dimensions was created from the literature. They include workstation height, chair seat height, deep seat depth and armrest height, keyboard, middle row height, monitor height, horizontal eye to monitor distance, eye to monitor center distance, shoulder to keyboard distance, mouse height, leg minimum height, and minimum height clearance, shoulder to mouth distance, angle of knees, angle of elbow, and angle of hips. These measurements were made from each workstation beside a noise, light, temperature, and humidities at each workstation were measured. Noise was measured in decibel in amplitude at ear height of a sitting employee using a noise level meter. Light was measured in lux on the employee's desk using a light meter. A temperatures and humidity meter was used to measure temperature and humidity at the workplace. Body posture was assessed through visual inspection. Participant individual perceptions on these attributes was assessed through the questionnaire. The ergonomics evaluation checklist. Ergonomics evaluation checklist of a computer workstation comprises of 4 sections: personal information, workstation and work information, medical information, and a satisfaction questionnaire. Yes, and a satisfaction questionnaire. Yeah. Satisfaction questionnaire. In all information sections, employees were asked to tick yes or no for each item, and in the questions on the Saturn factory, questionnaire on satisfactions, they were required to circle a number from 1 to 5, which is from very dissatisfied, and very satisfied, that best represent their reaction to a statement. There were 5 personal, 15 facilities related, 6 posture related, 12 workstation related, that are table, keyboard, mouse, monitor, and chair, 6 screen and glare related, screen glare related, 12 health related, 6 environmental, and 18 satisfactions questions, 5 questions on training, and 15 questions on dimensions were also included. 40 computer workstations, each used by one computer employee from an oil company, were selected for the study. The employees underwent a medical examination before they were employed. Therefore, no medical examinations was carried out before the study. The jobs of these employees included computer center support, financial operation services, terminal pipeline operations, and assets management. Therefore, the work regimes of the participants could be considered as routine. The offices were fully air conditioned, and between 1 and 5 employees occupied each office. All 40 employees who participated in this study completed the questionnaire. Participant information. Information on the participants is presented in the result. The participants had mean experience of 5 years on such jobs. The group comprised of 80% of men and 20% of women, and they were multinational. Their education ranged from diploma to bachelor degrees. Normal office hours were between 7 a.m. and 4 p.m. with a lunch and 2 coffee breaks. Their usual computer usage is present in the results. So if you look at the results, it will be the characteristics between age, weight, height, and computer usage between 1 to hour, 2 to 4 hour, and more than 4 hour per day, per one sitting and per day. Physical measurements. Recommended standard computer workstation dimensions. Temperature between 20 to 27 degrees Celsius. Relative humidity is between 50 to 60%. Workstation height should be between 700 to 800 millimeter. Chair height seat between 380 to 380 to 520 millimeter. Seat chair depth is between 380 to 430 millimeters. Eye to monitor distance between 500 to 800 millimeter. See the reference. Also see the reference from the Handbook of Industrial Engineering Technology and Operation Management from New York, United States, print in 2001. Physical measurement of workstations and employee positions were compared with this standard measurement. So is the results in the table. It shows the relative error calculated using the measure and standard dimensions as the follow. By the relative error and absolute errors, measure and minus with standard and divided by standard and multiply with 100%. So that is relative error. The highest relative error was for eye to monitor distance, while the minimum relative error was for chair and height table. The minimum relative error from eye to monitors was 89%, and the minimum relative error was 26%, indicating the distance was either much higher or much lower compared to the standard length of 500 to 700 millimeter. So we highlight between this distance of this distance eye to monitor distance. 80% of the employees use a computer table, while others use a normal office table for the computer. While 55% use a fully adjustable chair, such as height, back seat, and armrest could be adjusted. 45% use a semi-adjustable chair, only the height could be adjusted, while a fixed table height, work height, and semi-adjustable chair Workstation adjustments obviously was difficult. 55% report that they maintain a support and back straight back, while for 45% report a bent and unsupport back. This result is consistent with the fact that 45% did not use a fully adjustable chair. Most employees, 89%, had windows blind. Yes, had window blinds in the office. 53% used a keyboard wrist pad, and 55% used a mouse wrist pad. This indicated that about half of employees neither used a mouse nor keyboard's wrist pad. These forced hand postures, deviations from natural postures, and only 13% of the employees use a document holder. A document holder can relieve an employee from unnecessary neck movement and poor posture. The position of the employee with respect to the monitor and keyboards was aligned in 83% in case of while the either of keyboards was in front and the monitor on the side or vice versa. This non-alignment indicates repeated turning of head and hence deviations in neck natural postures. In 48% of the workstations, the computer screen was facing window and create a source of glaze. This was glaze. Source of glaze. This was confirmed when 40% of the employees report that the window was the source of glaze. 15% of the employees believe the source of glaze were the windows and overhead light. Authors could not recognize the source of glaze. Author could not recognize the source of glaze. 25% of the monitors were fit with glaze filters. Physical environment. Although the physical environment could be controlled, 25% of the employees reported heat, 23% noise, and 18% light problem in the office. Measurements of this attribute showed a temperature range from 22 to 28 degrees Celsius. Noise range from 50 to 56. No, 65 decibel. A light range of 250 to 600 lux. That was close to the recommended light level in the office, which is related less than 10%. Yes, light. And then the variations in temperatures in the office was due to the common office arrangement in some employees and high temperature outside during summer month. Noise could be considered normal. However, telephone noise could be disturbing in common office and therefore some employees complained about a noisy environment. Health problems. Health problems. Health effect or work-related health symptoms were highly significant. A wide variety of health problems was reported. 58% of the employees report eye strain. 45% shoulder pain, 43% back pain, 35% arm pain, and 30% wrist pain, and 30% neck pain, 23% leg pain. These two dominant problems, eye strain and muscular skeletons, are indicate of ergonomics deficiencies in office computers workstations. Eye strain could be due to computer facing window, producing gaze, user to monitor distance, long hour computer use, and inappropriate lighting. Musculoskeletal problems could be due to poor computer facilities, stations layout, long hour in the same posture, and inadequate inadequate rest breaks. Other health issues were also significant. A correlation analysis was conducted with employee health, work and facilities, and environmental ergonomics training problems. So, look at the table. The correlation coefficients of 0.33 was significant and showed that the employees who did not have ergonomics workstation components had more health problems than those who did. The positive correlations of 0.34 between health problems and ergonomics training indicate that those employees who has poor ergonomics training also had more health problems. No correlations was found between employees' health and environmental problems. This was due to a controlled environment that did not have any adverse effect on employees' health. The correlation between the health and a combination of all problems was significant. This indicated combined effect of all problems affecting employee health. An analysis of satisfaction scores showed that a significant number of employees was dissatisfied with the various workstations component. 33% of employees were dissatisfied with the chair, 20% of the keyboard, and 20% with the number of rest breaks. A correlation analysis showed that employers who had no ergonomically designed components were more dissatisfied than those who did, with a correlation of 0.33. Most employees, about 82%, did not receive any ergonomics training. Among these, who has 54% were dissatisfied with it. No formal or mandatory training program was found in the company, except for some booklet and presentations. This was a significant positive correlation between ergonomics training and health problems. Employees with workstations ergonomics training had fewer train problems. Relation coefficients 33%, 0.33 coefficients, D than those who have not had it. So let's discuss this. The study was conducted in a large oil company with 40 office workstations, each occupied with an office employee. Although the sample was small, it represents a typical computer workstation, and the results obtained applicable are applicable to office employees using computer workstations. The study has resulted in a more detailed knowledge on ergonomics, ergonomics deficiencies, deficiency, ergonomics deficiency in office computer workstation and their effects on human health and safety. Physical layout and the dimensions of the workstations indicate a significant deviations from the recommended design and parameters. It was found that the components of the computer workstations did not conform to recommendations. Usual office tables to put computer on, semi-adjustable chairs and office chairs, lack of wrist rest, locating computer-facing windows, and poorly laid out office contribute. Yes, a poor laid out office contributions. Significant ergonomics problems. Report health symptoms were caused by ergonomics deficiencies in the computer workstation systems. Most participants, about 58%, complain of eye strain that could be due to the distance between the user and the monitor, computer-facing windows, and spending long hours in front of the computer. Results show that 55% of the employees complained of gaze in the workplace. That was probably caused by the computer screen facing windows. That was about 48% of employees had their computer screen facing windows. The absolute errors of deviations is 58%, what maximum for the user to monitor dimensions. User to monitor dimensions. 58% of the computers were facing window, causing glaze. These deficiencies probably contribute to employee eye strain problems. Musculoskeletal problems such as back, shoulder, and arm pain were significant, indicating effects of ergonomics deficiencies in the workstation system. It was evident from the results that some employees were using computer table for their computers, office chair, and semi-adjustable chair. Most employees did not have document holder that are important for minimize back and neck bending, especially for those who spend a lot of time on data entry. There were no wrist rest, neither either. These conditions, occupied with long hours of computer usage, could cause body discomfort and musculoskeletal problems. Maintaining a correct posture, upright and natural, at work eliminates unnecessary stress on body part. Hence, it reduces musculoskeletal disorder. 45% of the employees were observed bending their back and not using backrest for supporting their upper limbs. In some cases, a keyboard was not aligned with monitors, and employees twist their body to use keyboards or look at monitors. Some employees were not using their adjustable armrests. This type of the layout could cause discomfort and health complaints. Although it is recommended that a short break must be taken every 2 hours of computer usage. Most employees spend over 4 hours a day without proper rest breaks. This obviously contributes to health problems as employees continue to be a fixed posture for a prolonged period. Employee satisfaction score indicated that 54% of the employees were not satisfied with the ergonomics training they had received. In fact, training in this respect was only to provide guidance and posture presentations. Systematic trainings in ergonomics on the layout and usage of computer workstations could have eliminated many of the identified deficiencies. The employers were not satisfied with that type of chair they were using. Ergonomically designed furniture can reduce posture discomfort and reduce musculoskeletal and posture problems. Although the guidelines and recommendations on computer workstations are available, implementation of this is lacking, causing serious ergonomics deficiencies in the workplace. And the recommendation, based on the results of this study, the following conclusion could be drawn on the ergonomics deficiencies of the computer workstation. Ergonomics deficiencies were significant in physical design, component layout, employee posture, work practice, and training of fixed computer workstations. There was a positive and significant correlation between worker health symptoms and workstation facilities. State otherwise, poor workstation facilities contribute to more health problems. Computer workstation facilities and furniture were in referred to is were inadequate, which may have contributed to ergonomics deficiencies in terms of layout and workstation organization. May I repeat again? Computer workstation facilities and furniture were inadequate, which may have contributed to ergonomics deficiencies in terms of layout and workstation organization. Office employees were seldom provided trainings in proper computer workstation layout and use. Absolute errors, deviations from recommended standard measurements, were high for wheeling distance, which could have contributed to eye strain. The following recommendations were made in order to rectify the ergonomics deficiencies. Ergonomics deficiencies identified for computer workstations in office environment. Computer workstations in office should be laid out following ergonomic standards, guidelines, and recommendations. Employees must adopt a natural posture with back support and follow recommended guidelines in computer workstation usage. Ergonomically designed facilities such as workstation components should be provided in order to better maintain and follow ergonomics standards. Employees must be trained in ergonomics layout and organizations of their workstations.